In this video, we're going to look at determinants and how we can find determinants of particular square matrices. So what we'll see here is that every square matrix has a real number that we can call its determinant. So what we need to do is to define what a determinant is. So given a matrix A, the notation that we use for determinants is either labeled with DET parentheses with the matrix label in it. Here we get A, or we'll use the symbols that we usually see as absolute value, but this is going to determine what a determinant is in matrix notation. So you'll see the absolute value bars for this. So let's define this. For any 2 by 2 matrix labeled A with A, B, C, D as its elements, the determinant is going to be defined as this. We're going to take A times D, which happens to be the left diagonal, and we're going to subtract from it B times C, which is the left diagonal out of this. We will always multiply, kind of like cross multiplication here. We'll find out those two numbers as a product, and then we'll subtract between them, and that number will be called its determinant. So let's take a look at a few examples of finding a determinant. Here we have a matrix A with elements -4, 3, 5, and -10, and we're going to do some cross multiplying here. Take the products and subtract between them. So what we would do here is take -4 times -10, which will give us 40, and then we're going to multiply 3 times 5, which is 15, and we subtract the two numbers. 40 minus 15 will give us an answer of 25, and this is the determinant for this matrix A. A second example, we got elements -6, -3, 11, and -2. Again, sticking with our rule, we'll take -6 times -2, which is 12, and we're going to subtract from it -3 times 11, which is -33. We got a double negative, so we're adding 12, and minus -3 gives us 45. So there's the determinant for matrix B. Let's look at one more 2 by 2 matrix. We have a matrix C. We will take 5 times -9, gives us -45, and we're going to subtract from it the left diagonal, which is -7 times -5, gives us 35, and -45 minus 35 will give us -80. So that's just finding a determinant, and that's using the definition of determinant for 2 by 2 matrices. What happens if we get a square matrix larger than a 2 by 2? More specifically, a 3 by 3 determinant. We need to figure out how to come about that real number. So determinants of a 3 by 3 matrix. We're going to go through 4 steps here. The first step, we need to rewrite the first 2 columns. So we're going to take column 1, column 2, and we're going to copy them just outside the 3rd column in the matrix. Then we're going to find the sum of each left diagonal. So we're going to start in the upper left-hand corner, and we're going to find the product of the 3 numbers that make up that diagonal. And we'll come up with 3 different products. So it'll be 3 left diagonals, and then we're going to go back in and do this again, but now we're going to do the right diagonals. We're going to have 3 separate right diagonals. There we'll come up with those products. We'll add them all up. And then finally, we're going to take our answer from step 3, and we're going to subtract it from our answer from step 2, and that will be the determinant of a 3 by 3 matrix. Let's take a look at an example. Here we have the 3 by 3 matrix A with all of our 9 elements here. Step 1 says to take the first 2 columns. So we'll take column 1 and column 2. We're going to simply just copy those just outside of the matrix here, which will look like this. Now we can do step 2, which says let's multiply all of the left diagonals here. So we'll go ahead and take -3 times 4 times, not -3, but 3 times 4 times -1, and come up with this product. So that will give us -12. And then we're going to come in and do this again. So instead of starting at 3, we're going to jump over to the next number, -7, and we're going to take -7 times -5 times 1, get its product, which is 35. And then finally, we have one more diagonal here. We'll go 2 times negative 5 times 5, which will give us negative 50. And those three numbers there, we're going to add them up, and that will give us all of the sum of those products from our left diagonals. Negative 12 plus 35 minus 50 gives us negative 27. Okay, so we're halfway done. Now we're going to start in the bottom left-hand corner. And we're going to go with 1 times 4 times 2. That product will give us 8. Jump over to 5. 5 times negative 5 times 3. That product will give us negative 75. And the last diagonal that we're going to multiply will give us negative 1 times negative 5 times negative 7. And that product will give us negative 35. And just as we did with all of our left diagonals, all these right diagonals, we're going to add up 8, negative 75, and negative 35 to give us negative 102. What we will do with these two numbers then is we're going to subtract them. So our determinant of this matrix A is negative 27 minus the negative 102, or in other words, 75. So we will say that the determinant of this 3 by 3 matrix is the number 75. One more example with a 3 by 3 matrix. Here we have matrix B. Go with our step 1. We'll take our first two columns. We're going to copy those just outside the matrix. And we'll go through and do our products of 6 times 4 times negative 4, which gives us negative 96. Jump over to negative 3 times 2 times negative 3. That product gives us 18. One more diagonal here, which is 6 times negative 1 times negative 6. That product will give us 36. Add up all of those products, and that will give us negative 42. Took care of all the left diagonals, so now we'll start in the bottom left-hand corner of our matrix and go with negative 3 times 4 times 6 to give us a product of negative 72. Go to negative 6 times 2 times 6. That product is negative 72 once again. And the one last diagonal that we have here is negative 4 times negative 1 times negative 3, which will give us negative 12. Add up all of these products to give us a total of negative 156. And the last thing we will do, again, is just subtract the negative 156 from the negative 42. So the determinant of matrix B will give us 114. So that was a really short video to show us how we can use the diagonals to come up with a determinant of a 2 by 2 matrix and a 3 by